So this doesn't help us. You see, we've talked about this, but it doesn't help you because all I needed you to do was to understand the principle of the intermediate value theorem, but it doesn't help you to solve it. Now, how do you solve it? So the thing of it is, sorry for that glitch. Now let's just put how you solve it, because squeeze theorem is also quite similar, but there's a major difference, because for intermediate value theorem, you are proving that there is a solution. For squeeze theorem, you are finding a limit which is also in between, which you can't solve directly. So you will be proving that there is one on the left, one on the right, and then whatever. Let's start with the intermediate. So for intermediate theorem, remember, intermediate value theorem, you are proving that there is a solution. If I do like this, we saw that if you take a value which gives you an answer which is negative, and another value which gives you an answer which is positive, then in between those two x values, there is one which is going to give you an answer which is 0. That answer which is 0. And that x value is between x1 and x2. It will always be between x1 and x2. x1 is giving you negative. x2 is giving you positive. So between them, there is one which gives you 0. Okay? So let's go ahead and let's prove. We'll be just proving that. Just prove. Look at how simple it is. So that is what you'll be. All you're going to do for intermediate value, you're going to see us using it. We are going to put a value in our function and get a negative answer. Then put another value in our function, then get a positive answer. Once it's like that, we are going to say, therefore, that means between x1 and x2, there is a solution. So you're going to have it. So let's say if we put a value, the thing of it is, sometimes they will say, prove that there is a solution or a root in the interval 1, 2. If they say in the interval 1, 2, they are already telling you that between 1 and 2. So you are going to put 1 in your function and get an answer, and it's going to be negative or positive. Then you put 2 in your solution, in your function, and it's going to give you an answer which is going to be negative or positive, right? And if 1 has given you positive and 2 gives you negative, that means there is a solution. If 1 gives you negative and 2 gives you positive, there is a solution. So they should just give you different signs. And now sometimes they will just say, prove that there is a solution and not give you an interval. If they give you an interval, wow, that's so easy. Because if there is a solution, then one should give me negative, the other positive. But sometimes they'll say they'll give you proof that cos x equal to x has a solution. How do you prove that? Now, what you're going to do is, if you get a thing like this, so for intermediate value theorem, what you must do is, first you make sure your function is equal to 0. You make sure your function is equal to 0. So we take x to the other side. We have cos x minus x equal to 0. Once it's equal to 0, we let this guy which is equal to 0 be f of x. So you let f of x be equal to cos x minus x. Then what you're going to do is, you are going to start putting values in here. Remember, they just said, prove that it is a solution. They didn't tell you between what and what. So now you are going to look for where the solution is. You're going to test 0, 1, 2, and 3. The solution is going to be between these values, okay? So you're going to find f of 0, and here it will be cos of 0 minus 0. Cos of 0 is 1 minus 0, which is 1. And what is this? A positive. Now, we will try f of 1. So if the solution is between 0 and 1, that means 0 will be positive like it is, and 1 should then be negative. So if we put f of 1, that means where there is x, we are now putting 1. So it will be cos of 1 minus 0, okay? Then you just punch in your calculator and see what answer you get. Cos of 1, you get 0.0 whatever. And we say minus 0, you get that 0 point whatever, which is still positive again. So that means the solution is not between these two. So I mean, let me punch cos 1 into the calculator. I'm punching it. This is going to give me, and if it's in rad, it's going to give me 0.54 blah 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 blah. Even let me see what it does if it's in degrees. Let me see if the answer is going to be different. Give me a sec. So either way, even if I use degrees, even if I use rad, because for degrees it is giving me 0.999998, you know, which is still positive. And it was like, for rad I got 0.5 whatever. So you can still use it. Here we are just saying that there is no sign change yet. Now we are going to put f of 2. Although I would probably suggest that you use radians, because you're going to use radians for almost everything. Even if you see your graphs, we were using rad instead of degrees. So I'll just put my calculator in rad and use rad for consistency, okay? So I would say what is cos 1 rad is just going to be 0.540. So it's still positive, 0.540 what, which is still positive. Then what is f of 2 is now cos of 2 minus 2. It's cos of 2 minus, sorry, this is cos x minus x. So this is cos of this minus 1. Oh my goodness. You're right. So this was supposed to be cos 1 minus 1 because it's cos x minus x. So it's supposed to be, what is it? Cos 1, I get this. Then I say minus 1, I'll get a negative value because I'll get a negative 0.45. So it's going to be negative 0.4596, blah, 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 blah. So this is a negative 0.4597, okay? Or you can say just negative 0.46, which is a negative value, okay? I almost made a mistake there, oh my goodness, but it doesn't matter. So here we have seen that there is a sign change. One was positive, the other one was negative, okay? Remember, you are just going to be putting values in a function. It's not hard. No, you let your function be equal to 0, then you make your function be equal to 0, right? Then you let f of x be this thing which is equal to 0. Then you start to put in 0, 1, 2, 3, until you see a sign change. So if one is positive, then the other is negative, then we know that we have arrived. So we know that between x0 and x1, there is an x which will give you an answer of 0, right? So now you can say, since what you're going to write is since f of 1 is less than 0, because f of 1 is the negative one. You start with the negative one, which is going to be less than f of 0. So here you have just said f of 1 is negative and f of 0 is positive. So you have just shown that there is a sign change. Then you can now say by IVT, by intermediate value theorem, you can write it in full in the test. There is a value c, okay, or a value x equal to c, okay, such that f of c is equal to 0 in the interval 0 to 1. Okay, so there is, you've already now said everything. You said there is going to be a value which will give me an answer of 0. Remember, that is a solution. You can still write to say, since this is going to be, since f of 1 is less than 0, which is less than f of 0, by the intermediate value theorem, there is a root. You can still say there is a solution. Okay? In the interval, you can still say there is a solution in the interval 1, 0, 1, or between x equal to 0 and x equal to 1. You can still say this. Or you can still say there is a value which gives you an answer of 0. Remember, we said a solution or a root is a value which gives you an answer of 0. You got one which gives you an answer of negative, and the next one was giving an answer of positive. So in between those two, there is going to be one which gives you 0. You are done. That is what you'll be just doing by the IVT. So the IVT is just simple like that. Okay, we're going to see many other solutions. You can go and check. I've recorded those for you, the tutorial solutions, and you can go through them. Okay, you can go through them and you can see. And now it's about practice. It's about practice. But you know what the intermediate value theorem says now. Now, what about the squeeze theorem? Well, the squeeze theorem, let's talk about it. I'm going to talk about it in the next video, so we keep this on short. All right, goodbye for now.